Okay, we'll be starting in about 1 minute. So in case there's any more people coming in. Okay, I guess we'll begin now. Good evening, ladies and gentlemen. Welcome to this week's Security Wednesday, organized by Grey Hats. I'm Desmond Tan, your host for the event today. This week, we have invited 2 guests to share about information security. First up, we have our own Grey Hats member, Debbie Tan, who will be sharing about cyber risk management. Debbie is a final year undergraduate student at NUS, majoring in information security. She previously graduated from Nanyang Polytechnic with a diploma in cybersecurity and forensics. As part of her role as a CISO in summer intern at UBS, Debbie contributed to a white paper on cyber risk quantification. Cybersecurity has been growing in importance and frequently plays a key role in organizations in this day and age. With the recent growth of cyber threats and implementation of new cybersecurity laws, the consequences of exploited cyber risk have increased exponentially as well. As cybersecurity specialists, how can we translate such costs and benefits of new security controls into something that can be universally understood across the organization? In this talk, Debbie will be giving a brief introduction into quantifying cyber risk and discussing how we, as cybersecurity specialists, can help our organizations make smarter cybersecurity investments. Without further ado, let's welcome Debbie.
Thanks, Desmond. Okay, can everyone see my screen? Desmond, okay?
Yeah, no problem.
Okay, great. So, hi everyone, I'm Debbie. Today I'll be talking about cyber risk quantification. So basically, it is a new topic with cyber risk management, and this is something that I did during the internship and would like to share more about. So, okay, running through what we'll discuss today, we'll start off with understanding what cyber risks are, as well as the organizational impacts of cyber risk, followed by how we quantify them, and finally, how do we make cybersecurity decisions? So, what are cyber risks? So, according to NIST, cyber risk is the risk of things depending on cyber resources. So, for example, when you use a machine to, for example, search for data on a database. So you're relying on the database for information. So that is a potential cyber risk because you're relying on that resource. So, for example, anything that goes on the cyberspace basically can become a possible cyber risk. So I'll give a short example here that we can relate, hopefully. So most of us use data and like mobile data and Wi-Fi every day, right? Like how you're attending this call right now. You're probably on Wi-Fi or mobile data. So what if it fails for 30 minutes, starting from like right now? Then you'll miss 30 minutes of the talk, right? So what would that cost you? So it could cost you information if this is something that you're interested in and would like to hear more about, or it could cost you, like maybe if this happened during an exam, It could cost you grades. There is like a variation of different types of costs to it. So later on, I will delve more into how you can actually quantify this cost and how this can help you make better decisions in terms of cybersecurity and business. Okay, so let's extend this idea. Just now, it was about one person, how it will affect you. So what if this affects like 100 people? How would that, what kind of impact would this cause for 100 people, the 100 affected people? And how much would it cost in total? So this is important for a business. It doesn't just affect one person or a particular individual. This can affect the entire business as a whole, the public, and depending on what kind of industry the business is in. For example, if it's a bank, you can possibly affect like internet banking, like people can't pay for their food for maybe 30 minutes. Then what would that cost? It's a huge like damage right there, isn't it? So now I'll move on to like organizational impacts, which is linked to what I've mentioned previously. So I want to go through a quick activity with everyone right now. So if you guys will be kind enough to sign on to this QR code, I would like to hear things about like what are some organizational impacts of cyber risk that you can think of. So if you can't access using the QR code, there's a link right at the side here where you can sign in. Then I will showcase the results shortly. Yeah, let's just do this for about 3 minutes or so. So I love the first reply, lose money. Yeah, very true. So this can actually cause like huge financial damages to companies, especially like infrastructural companies like banks, your energy supply, like your electricity right now, or things like Zoom, right? Yes, credibility, it damages credibility, causes people to causes organizations to get like a bad reputation, loses time, especially like for example, we're all taking an exam, and if NUS Luminous goes down, then like what's going to happen, right? Yep. Are there any other additional inputs people want to put? Documents, my job. Okay. Yep, that's a very good point for those who are going into technology for career. Lose customers, yes. What kind of losses? Like, yes, you can lose resources if, let's say, if it's a power outage or a sudden server failure. Yes, you can lose that potential resource perpetually. Then you may have to replace it with a brand new one. Intellectual property. Yes, I would say so, for like data breaches and all that. Okay, cool. So, oh wow, there's more coming in. Okay, I guess we can move on back into the slides then. Thanks everyone for your input. So, okay, moving on the slides. So, I would like to emphasize that cyber risk exists on many different levels. It can exist on, it isn't just about like information on a certain level. Like you can, like what can potentially pose a cyber risk can include like humans like us. For example, someone writes their password on a post-it note. The IT admin writes his password on a post-it note and leaves it on his computer, and people can just access the account, right? So this is, I actually broke it down to like 5 different risk categories. So we have like human risk, data risk, cyber risk, operational risk, and infrastructure risk. So I would like to emphasize that cyber risk isn't just about getting compromised. It's also about how you can get compromised. It's important to understand the root cause, right, of how this entire thing can even happen, because that's how you can truly prevent it on a better level, on a more sustainable level at least. So I'll start off with talking about operational risks. So cyber-related operational risks can it basically is the risk of failure resulting from any sort of like failed process or like inadequate process. For example, maybe not storing your passwords properly using a hash. That's one example. Or maybe the process of allowing your employees to write their passwords on post-it notes, not using a password manager, maybe not changing your passwords every 3 months. That's a potential like failure in a process. And you'll soon realize that different types, like the different categories can actually overlap on certain levels. For example, operational risk, but it can also involve humans. Like, for example, if you allow people to write their passwords on post-it notes, people don't have to write it on post-it notes. But if they choose to, then it becomes a risk, right? So I would like to move on to like human risk. It is basically any sort of like human error, the risk of human error that can allow a successful hack or like data breach. For example, if a particular administrator likes to use password 123 as his or her password, then by using a simple attack, if there is not enough security measures in place, that can already result as a potential hack or data breach. Or even hackers could pose as a employee and just like, you know, common courtesy will open the door will like hold the door open for people. And that can already result in a potential data breach. So later on, I'll talk about all these, like how do we quantify them and some possible solutions that we can apply to help us gain better control over all these risks. Another type of risk is cyber risk. So malware. Yeah, or in layman's term, viruses. If we could get infected with like a ransomware, right now it's really popular, and it could lock everything up, and this could potentially create a cyber incident when it comes to a large organization. And then do you pay the ransom or not at that point in time, right? It can be quite a hard decision. So in general, I think companies try not to pay the ransom because ultimately you'll be funding whichever syndicates behind it. And then we have data risk, which basically results from poor data governance. So like maybe a process on confidential customer data is not properly enforced. That could result in creation of a new data risk, a new potential attack vector. And this can ultimately result in severe consequences like PDPA breach and all that. And it's very expensive. PDPA, if you get a data breach, PDPA can fine up to 1 million or more, depending on the severity. Yeah. And finally, we have infrastructure risks. So like our servers and all that. Basically, when it comes to infrastructure risk, it's about our devices. So it's important to like, for example, not use your work laptop for like personal users if let's say you're provided with one, and like have the proper antiviruses, anti-malwares installed and updated in this case. Yeah. So moving on, I would like to talk more about cyber risk quantification, which is the bulk of today's topic. So basically, how we already know what kind of cyber risk we have that we can potentially face as an organization or as an individual. So how do we quantify this? It doesn't just apply to organizations. You can even use this to choose whether you should buy your antivirus or not. So I guess depends on how you apply it. So there are different types of cyber risks that I would like to categorize them into like two big groups. Basically, we have the operational costs, where we can quantify them we quantify them clearly, and then we also have repercussion costs, which is a varying type of cost. So for example, if it's a large data breach like the iHIS data breach, SingHealth data breach, maybe some of you may have heard of it. In that case, I would say that the repercussion costs are actually significantly higher than a smaller scale data breach that has lesser media attention on it. Because ultimately, what we're talking about when it comes to repercussion costs is really reputational loss and like losing customer trust. And when it comes to operational costs, it's something that we can like calculate clearly. Like for example, downtime. How much does it cost us per minute every time our systems are down? And how much revenues are we losing in terms of like when it comes to operational disruptions and all that, as well as like regulatory fines. So like PDPA, data breach costs, like those kind of fines would fall under operational costs. So how do we measure cyber risk? I would say that it's basically likelihood over impact, like likelihood times impact. So these are two main factors we have to consider when it comes to measuring cyber risk. So impact could include like business criticality. So how important is this particular asset to your business? So for example, if it's a laptop of maybe a particular marketing personnel that has been like locked for an hour, it may not have as high of a business criticality as compared to, let's say, your main server being locked for an hour with a ransomware or something like that, right? So there are varying levels when it comes to measuring how critical an asset is to your business as well. And the second thing is the likelihood of a certain cyber incident happening. So like ransomware is pretty common nowadays when it comes to, for example, banks or like healthcare industries. They are more highly targeted, especially with the COVID pandemic going on. So likelihood can include like vulnerabilities, exposure, how exposed your certain asset is to the outside world, or maybe even insider threats. How like the severity of the threats that you're facing, and what kind of existing security controls you have in place right now. So with that in mind, how do you decide what's good? All right, using cyber quantification, cyber risk quantification can actually help you make smarter choices. So you can measure risk based on the existing security controls that you have versus the risk that you're facing based on your new security control, and whether it actually measures up and make a worthy cybersecurity investment. So with that said, I would like to move on to talk about making cybersecurity decisions. So I would like to raise a simple case study for everybody so we can actually get a better feel on how we can apply cyber risk quantification to our daily lives. So for example, we have company A who is in the healthcare industry, and your available budget is really little. It's 100K, 100,000. And the possible threats that you're facing include like malware, ransomware, spyware, phishing, which is like done via emails, etc., websites, as well as the denial of service, which is something that can actually impact many lives, especially in the healthcare sector. For example, if you're a hospital, this can actually like damage people's, like for example, life support machines in the future, right? Especially if they're connected to like the internet, or even change patient data. For example, if your patient has diabetes, someone change it to like blood pressure, then what's going to happen now, right? You may or may not notice the difference, especially when it comes to like you're facing like maybe hundreds of patients moving in and out of the hospital every day. So option one, you would like to have a new security control to prevent the data breach of your personal health records that your company actually holds. So how much would that cost operationally, right? So in terms of operational downtime, I got the numbers from Google. I will put it out there first. So they estimate it to be about 5,600 per minute. And the regulatory fines, PDPA, is up to 1 million or higher. Now, if you earn above 10 million, then they will charge you 10% of your revenue. So for example, if you face a downtime of 1 hour with a leak of 500,000 records, then the downtime would be would cost you about 336,000, and then the regulatory fines may be up to 1 million, and that will actually cost you 1.3 million. So thinking about security controls that you like to put in place. For example, you have found a good one and you need to hire new talents. That could be average 5.7K a year. No, sorry, 5.7K a month. Typo there. An estimated duration of 16 months. So on top of that, you have to consider whether you have any like licenses or tools that you need to purchase. And for example, if you need a team of 10 specialists for 16 months to build a new cybersecurity control and enforce that in place, that can cost you 83,000, which is a pretty good amount compared to like 1.3 million, right? You're saving a good amount of money, preventing a potential like data breach. But when you bring this to the business, they may not see it that way because this is a may happen and this is a definite cost, right? So how do you sell that to upper management? You can tell them that, then that's where you bring in like repercussion costs, like reputational damage. That's something that they'll understand for sure. And on top of that, you have like facts and figures here, right? So this is one example of how you can apply cyber risk quantification when it comes to marketing a certain security control that you like to enforce in the future to your organization. Yeah. So what will you choose, right, when it comes to this? Cyber incident cost is going to be $1.3 million. The risk, cyber risk that you are facing with the new security control in place, 83,000. And you could potentially save 1 million. So of course, we'll choose the facing the risk with the new security control, right? Because the risk has been significantly lowered now. But let's say you have option 2, then you only have 100,000. So your option 2 is preventing the main server from power outage, or at least preventing it from damaging the services that you provide as company A. So how much would this cost operationally? Using the same figure that we had just now, operational downtime, it would be 300K, about 236K for 1 hour of downtime. And how much will your security control cost? Considering offsite costs, hardware costs, software costs, the admin cost, and reducing operational downtime to 5 minutes instead of an hour, it will cost you 62,000. Not as big a difference, but this can also potentially save customer lives, like patient lives. Because especially when it comes to, for example, if you're a hospital, A&E, you need to pull data up immediately. You need it right at that moment, and 5 minutes can change a person's life. So this is important as well, isn't it? Like, this is not any less important than option 1, where you prevent a data breach. One is about privacy, confidentiality. The other is about keeping the power source up. But right now, you can only afford one. So yes, it really helps to lower the risk that you're facing right there. From 1 hour, you reduce the operation downtime to 5 minutes, which is a really good deal. But what if I say that you have to pick one? Because you only have 100,000 and you are saving 1 million on the data breach prevention and 200K on the power outage recovery. What will you choose? Maybe you guys can put it in the chat and then we can see what will everyone decide on. So given a choice, would you choose to prevent a data breach, or will you choose to prevent power outage or significant damage from a power outage? Or just give us like a minute or so. You guys can just type it in the chat, or if you're shy, then once the minute is up, I will move on. No messages? Okay, I guess I'll move on then. So, oh, okay, we have one. power outage as in like the main server running out of power, and then it goes down, you're unable to retrieve data from the from the main server, like for example, patient data. So this, for example, company A is a hospital, and you need to retrieve data that you have from a patient that just came in the A&E. If you use power outage recovery, then you would reduce the downtime from 1 hour to 5 minutes. When it comes to data breach prevention, you reduce the possibility of getting a data breach and damaging your company's reputation. Yeah. Okay, never mind. So moving on. It's hard. It's a hard decision, right? So I would really just like to emphasize like how cyber risk quantification can actually help you in terms of making cybersecurity decisions. So in this case, if you have more budget, you can actually have both. But at that point in time, for example, going back to the previous slide, at this point in time, you would be considering your priorities. So you may choose to place the money into power outage recovery, even though it brings lesser loss of revenue, but it can save lives. Or you may choose to protect the company's reputation by investing it into data breach prevention. So this really helps you weigh out your priorities and how you want to spend that amount of money more wisely. And of course, it also helps you bargain for a better budget next year. Okay, so that's all for my presentation today. Thank you everyone for your kind attention and for coming for our Grey Hats Security Wednesday. And I would like to extend special thanks to Lionel. He was my line manager during my internship at UBS, and he actually introduced me to the idea of cyber risk quantification. And we actually worked on the white paper together where I got to learn more about cyber risk quantification, as well as read up on like how he learned about it from especially like papers with BCG, Boston Consulting Group. And yeah, that's why I'd like to extend special thanks to him. Yeah, thanks Lionel if you are here in the call. And any questions right now? So if you guys would like to get connected on LinkedIn, I've placed my LinkedIn here. And if any questions, you can type it in the chat. You can unmute yourself, ask questions, or whichever. Yeah. Okay, so I'll just check the chat. Okay, Aaron, so I see you opt for power outage recovery. So yes, I guess I would say that either one is a good choice. Right now, while opting for power outage recovery, you really would save patient lives. And yeah, I think that's a good option, given like if you only had 100K and you had to spend like either or, spend on a either or option. Yeah. Okay, Daniel asked one question and one suggestion. As a CISO summer intern at UBS. You're asking for the white paper. So right now, it is still with UBS, and I'm not sure whether they will release it. But if you're really interested in this topic, you can read more about it. There is this guy, Phil, I can never pronounce his name. Venables. He wrote a really good short article on cyber risk quantification. And let me just quickly send it to you. Cyber risk quantification. Okay, Daniel, you can Google this. You should be able to find like a list of his articles. He talks a lot about risk and cybersecurity. So in the event that the white paper does not get released yet, or maybe like it may be a while before it gets released, you can just check it out here. Yeah, Phil Venables. I don't know if I got his name right. I'm sorry if I butchered his name. Comment. As far as I know. Yep, you're welcome. And cool, thanks for sharing the comment. I actually didn't know that the world's first commercial cyber risk pool is in Singapore. So yes, I'll be reading up on the article later. So if anyone else has any questions, you can just type it in the chat and I will answer them. No questions? Okay, so if there are no further questions, I'll be attending the networking session later as well. And if you want to ask anything, then you can also do so. You can ask about cyber risk quantification. You can ask about my internship at UBS. Although I did speak about it a little last week as well. So yeah, thanks everyone for coming for my talk. And then I'll hand time back over to Desmond in that case. Thank you.
All right, thank you, Debbie, for sharing this insightful speech with us. Our next guest will be sharing shortly in about 5 minutes, so feel free to take a short break and come back then. Okay, I think we'll resume with our next talk. So next up, we have Terry, who will be sharing with us about static code analysis. Terry is a security consultant at Centurion Information Security. He enjoys reverse engineering and fuzzing applications in his spare time. Static code analysis is a powerful tool for finding bugs in code. In this talk, Terry will show off the power of Semgrep, an open source static analysis tool for matching complicated code patterns. The talk will demonstrate the power of hundreds of community contributed Semgrep rules, as well as provide us with a brief tutorial on writing custom Semgrep rules. Without further ado, let's welcome Terry.
All right, thank you. So let's get started. The topic I'll be talking about today is static code analysis with Semgrep. So just a little bit about me. I'm currently a security consultant at Centurion Information Security. And I like to do things like reverse engineering, fuzzing, like learning about program analysis, and just a bunch of like other random interesting things on my free time. There are a few places that you can find me online, mainly my GitHub and my blog. Or if you have any queries, feel free to email me after this. Right, so the topic of today is Semgrep, which is a static code analysis tool by a company called R2C. I think the full name for it is Return to Code. And Semgrep is not actually a new tool. So a little bit about its history is that it actually originated in 2009 when Facebook developed and released a program analysis library called PFFF. I'm not sure that's how you pronounce it. And it actually contains a utility called SecWed. And I think in probably 2018 or 2019, I'm not that sure about the timeline. It was actually forked by R2C and later renamed into Semgrep in 2020. So what's interesting about Semgrep as compared to the other like static code analysis tools available? I think the first and probably one of the more important points is that it's an open source tool licensed under the LGPL 2.1 license, and it doesn't actually cost you any money to use. So if you are familiar with like the traditional static code analysis tools, they are actually pretty expensive, like on the level of contact us for a code expensive. So to have a free and open source tool with actually quite a lot of capabilities is quite attractive to like students or even like individuals and small companies that cannot afford 5 or 6 digits to buy a tool. Semgrep has actually pretty good language support. They have different classifications on what is supported. So the general available ones, meaning like the most highly supported ones are things like Golang, Java, JavaScript and TypeScript, Python and Ruby. So it kind of covers a lot of the modern languages that you will see today. You will not find support for something like very weird or historic like Haskell or Erlang, for example. But I think it covers a lot of the like mainstream languages. There are a bunch of other languages in various levels of alpha and beta support, namely things like Rust, C, C#, PHP. So don't actually let the label alpha and beta like fool you. I think they're actually pretty usable even today. So the way that Semgrep differentiates the support level is essentially how much of the language Semgrep understands, as well as for each language, what are the Semgrep features supported. So if you actually go to the link I have here, Semgrep has a very nice table with the like language maturity for everything that they support. So you'll see things like OCaml, even like CYAML, generic stuff like Jinja, ERB templates. And it actually tells you what is the parse rate and what are the Semgrep features that are supported for each level of support. So if it's something that's pretty common, like the standard matching patterns, you can actually use like the alpha and beta languages even today. Right, so just a little trivia about Semgrep's internal implementation is that it actually uses a library called tree-seater for language parsing. And this library is actually like the one that GitHub uses whenever you push code into their repository for syntax highlighting. So in theory, it's actually possible to extend Semgrep to support a lot of different languages. It's just that no one actually put in the work to develop that yet. So another attractive proposition of Semgrep is that it's very easy to come up with new rules, as we will shortly see in a quick demonstration I have. And there is a very active community like building and sharing rules online. So R2C has a GitHub repo with a lot of community contributed rules. So if we take a quick look at it now, you can see that there are a bunch of rules for a whole lot of different languages, categorized into like different like categories, libraries, and so on. So you have things like recommendations for cryptography when you're using like a specific library, or even like the generic stuff. Yeah. So how does it compare against other static analysis tools? And the one that I like to compare it against the most is CodeQL, because I think they're both pretty modern takes on static analysis, and they have very different capabilities. So if you look on the left, CodeQL has very powerful data flow analysis, stain tracking powers. So you can write a query that matches, for example, whether a user input flows into a particular function or class. You can do like source and sink matching and all your traditional stain analysis stuff. Semgrep, on the other hand, it's a lot less powerful. There is no support for interprocedural data flow analysis. There is no support for stain tracking and a lot of the more powerful features. But what it does get out of being less powerful is that it's actually very, very fast to run. I run Semgrep typically on a like normal laptop, nothing special, like 16 gigs of RAM. You don't need like a huge server to run Semgrep. Whereas on the other hand, CodeQL can be quite slow to run because the queries take up a lot of compute power. The other downside, maybe not downside, but another limitation of CodeQL is that it requires a buildable code base. Before you can even like run any queries using CodeQL, you need to give your code base to its tool to generate like a database of definitions. While this might not be a problem in most scenarios, once in a while you will just find yourself with like a single source file that cannot be like built, and you still want to run some analysis on it, which is what Semgrep allows you to do. You can just give it like a single file with a bunch of functions, or even like just one function, and Semgrep will run perfectly fine. So CodeQL also, I think, has a fairly complicated DSL for writing queries. It's a different, like completely different language that you have to learn if you want to like write new rules in CodeQL. And it's a data log variant, which might not be like immediately familiar to people. Semgrep, on the other hand, is very simple to write rules for, and the rules kind of resemble the language that you're analyzing. So if you're analyzing a Python code base, your rules will look fairly similar to Python. If you're writing rules for a Java code base, it will look fairly similar to Java. So I think the simplicity of Semgrep allows a lot of people, even like not just the security folks, to jump in and contribute to writing rules for a code base. Right, so how do you actually use Semgrep? Semgrep is a library that you can install from pip if you're familiar with like the Python like packaging tool. I won't go through details of how to install it, just look at the website. But let's talk about how you run Semgrep. So the most trivial way to run Semgrep is in the grep mode. So essentially just a replacement for your basic grep. And in this form, you'll use like the -e flag to pass in an expression that you want to match against. So in this case, we can match against print hello world. We will need to specify the language, in this case, Python, with the --lang flag. And then finally, we can give a like single file, or we can point it to like a directory of source code, and we'll run that expression against all of the supply inputs. And it will tell you everything that matches. So using Semgrep in like the grep mode, like interactive mode, is great for interactive usage if you just want to explore a code base. But if you have a bunch of rules that you want to match against, this is where the Semgrep rule set support comes in. And you can do the --config flag to pass in a single YAML file consisting of the rules, or you can pass in an entire directory of rules to match against your inputs. So a Semgrep rule is essentially like a YAML file that consists of one or more patterns and some metadata. So this high-level explanation is probably not that clear. So I'll just quickly jump into some simple demonstrations. Yeah, so I have 3 very simple demonstrations to show like the power of Semgrep. And feel free to interrupt if there's any questions. So I can't see the chat at the moment, so maybe Desmond can just let me know if there are any questions and I can take a look. Right, so let's do the Hello World example. So you'll see on the left here, I have a Python like source file containing like a few different variations of the print statement. And on the right side, I will have a Semgrep rule that I want to run. So if you can see the rule on the right, it's essentially just a YAML file consisting of an ID. So this ID, you can have like more than one of it in a YAML file. I just have one at the moment. You have a message that's like a description of the rule. So this will be printed out if the rule matches. And finally, you have like the language input, so saying that it's a Python rule. And you can also specify the severity flag, so kind of indicating like how serious this rule is if it matches. There are 3 different options for this. There's info, there's warning, and there's error. So they don't actually really do anything. They're just like a way for you to label the different rules that you have. And the first pattern that I want to match is essentially just print hello world. So what happens if I run this rule? So I'm not sure if that's visible to everyone, but what I have here is essentially the --config flag passing in my YAML file, and I want to run it against the single hello.py file that I have here. So if I run it now, you will see that it actually matches 2 different statements, the one on line number 2 and the one on line number 6 to 7. So even this very simple rule kind of demonstrates the usefulness of Semgrep over your typical grep, because it doesn't really matter if you have like things like line breaks or like, like a expression is split across 3 different lines. If it's the same semantics in the language, Semgrep will understand it and will match it correctly. And you can see that the rule on line number 4 doesn't match because, of course, the string is different. And the rule on line number 10, the line number 10 line on the left doesn't actually match because it's commented out. So Semgrep understands things like comments in your source code. So just to show another example, even on this very simple source file, in Semgrep, you can use the triple dot pattern to essentially match anything, right? So if you are familiar with regex, you can think of the triple dots here as kind of like a regular expression wildcard sort of thing. If I run this rule now, you will see that it actually essentially matches everything but the commented out lines, right? So including things like goodbye world and print s over here. So yeah, so if you're not interested in anything in your expression, you just want to like match it regardless, you can just apply the triple dot pattern. So what happens if you just want to match string constants? So in this case, I'm interested in matching this first 3 lines over here, but I want to ignore the one at the bottom. So how do you do that? So it's actually fairly simple. It's essentially just the triple dot pattern in like your codes for strings. So this pattern actually works even in strings. So if I run this now after modifying my rule, you will see that it matches everything but the last statement because it's not a constant string. So moving on to my second example, which I think will probably be a bit more interesting. So over here on the left, I have a Python file calling the OS module in Python, and I'm calling the system function to run some shell commands. So this is actually obviously quite a dangerous pattern if it accepts inputs from a untrusted source, because it essentially result in command injection. So I want to write a rule to match any of these patterns in my code base and hopefully tell the developers to change it. So let's look at the first example I have over here. So it's pretty similar to what we saw earlier. We have a rule ID, a message, a severity, language, and so on. And over here in the pattern, we'll match essentially anything that has OS system in it. So if we run the rule now, we can see that it matches the first OS system call, the second one, and the third one. It obviously doesn't match the os.popen command because it's not os.system. So I think this rule it's kind of useful, but not exactly, right? Because if it's a constant in your os.system, it doesn't really matter. It's not going to be exploitable, so I don't actually want to match on those. So how do I tell Semgrep that I want to match on line 6, but not line 4? And the way that you do it is using, show the rule. So this is the rule that will actually do what I want, and it kind of demonstrates a power of Semgrep in that you can actually nest or combine different rules in different forms to achieve the outcome that you want. So we've already seen the pattern key, but there are two new ones that we've introduced in this example. And the first is the patterns key. And this you can think of as a kind of logical AND of all the different rules within it. So this rule will only match if the pattern here and the pattern here are valid. If any one of them are not valid, the rule will not trigger on that line. And on line number 10 on the rule, you see a different key, which is the pattern NOT key, which is kind of like your logical NOT. So putting everything together here, what we are essentially telling Semgrep is that we want to match all of the OS system calls, right? So that's what line number 9 says, except for the ones that have a constant. So if we run this rule now, you will see that it only raises the line number 6 thing. So the interesting case over here is on lines 8 and 9 in my example.py file, because you can see that although number 9 looks like it's taking a variable, Semgrep is able to understand that that variable CMD originates from a constant string within the function. So it does a very simple data flow analysis, and it knows that CMD is a constant string, so it actually isn't matching the pattern that we have. So what happens if you want to add more than one of these patterns into a Semgrep rule? So in this case, what if we want to match os.popen in addition to os.system? So what we can do is we can modify our rule slightly. And we have a different key that we've just introduced in this pattern, which is the pattern.either, which is kind of like the logical OR. So if either one of these patterns match, the pattern either will be valid. So you can see that in this simple example, we have used logical ANDs, logical ORs, and logical NOTs. And we can combine these 3 different things in various combinations to achieve the outcome that we want. So what this rule is saying is that we want to match everything that's os.system and os.popen, except if the call starts with has a constant. So if we run this command now, you will see that it matches lines number 6 and 11, which is exactly what we want. Right. So let's show like the last example that I have. This is a pretty short one. So what we have over here is subprocess.run with a few different flags, shell equals to true and check equals to true. And they are in different orders on lines 4 and 6, but they essentially mean the same thing. So we want to write a rule here that matches any subprocess.run calls with shell equals to true, because that is a potential security vulnerability. So how do we do this is that we can just right, so what we can do is we can just specify like the subprocess.run pattern, and we can say that we don't care what's in the first position, and we don't care what's in the last position or anything in between. We just want to have any of the calls that have shell equals to true somewhere within the parameters. So if we run this now, you can see that it matches both lines number 4 and 6. So I think this is a pretty useful pattern because it actually works anywhere in your code, not just within your function parameters. If you have like a function body that you want to ignore stuff in anywhere in the body, sorry, you want to match a line in your function body that's anywhere within that function body, you can just do like the triple dots at the top and the bottom, and you'll match what you want. Yeah, so that's the demonstrations I have now. If there are no questions, I'll go back to the slides. Yeah. Okay, so I've shown, I think, 4 different Semgrep rules that you can use. Of course, that is not everything. Semgrep has a lot of different ones that you can actually combine in there. You can do things like, for example, pattern-regex to specify like a regular expression to match things that you want. Yeah, there's a whole table I've taken from the Semgrep documentation. I will not go through them one by one, but if you're interested in any of what they mean, do check out the documentation. I think the most interesting one in this table that I would just like to talk about is the semgrep-where-python one. And what this key allows you to do is actually you can write a Python expression to do the filtering. So if you think like your standard semgrep patterns are not powerful enough to express what you want, you can actually just like shell out to Python to like do that matching for you. So if you're interested in actually deep diving into how to write Semgrep rules, they have a very good tutorial online. You don't even need like a shell or anything to do it. It's entirely in the browser. So yeah, do check it out if you're interested in learning how Semgrep works. Yeah, so I would like to demonstrate 2 of the more interesting and advanced features that Semgrep has. And the first one that I want to show off is actually the autofix feature that Semgrep has. And it's the ability to specify like a fixed key in your rule that will show up as a recommendation whenever you run it. So what this allows you to do is that if you match a rule like using a dangerous function, for example, and you would like to recommend your developers use a alternative, like safer variant of that function, you can specify that in the rule itself, and Semgrep will like show that recommendation. And you can actually even like automatically apply that fix with the -- autofix option. Of course, this one is a little bit dangerous because you're just like modifying your code based on like a pattern, and it might not actually be valid in the situation. So if you're using the autofix option, you need to be very, very careful. But I think it's still pretty cool because it allows you to, as a developer, if you're writing some code locally, before you even like deploy it to your CI/CD pipeline or your repository, you can run Semgrep to automatically fix up everything. You can test it, make sure it's valid before you commit it. So let's just take a quick look at this feature. Right, so I have a single line file over here. It's a very simple basic example where you have a dangerous function call calling 3 different variables. And the rule that I have to demonstrate this feature is this. So what we are saying in this rule is that the pattern is dangerous function call with 3 different arguments. And we are telling the developers that, hey, you should, don't use this function, call the safe function instead. So if we run this rule now, yeah, you can see that the rule says that, hey, you're using dangerous function call over here. You should maybe automatically replace it with the safe call. Yeah, so what happens if I pass in the autofix flag now, right? So if I do -- autofix, you can say, hey, it does the same matching, but it actually modified the file. So if I cat the example file again, you can see that it was automatically modified into the safe function call. And Semgrep understands that, hey, you're doing these 3 different arguments. You should use the same arguments in your autofix, so it retains all of the information for you. So like I said, it's kind of useful, but also dangerous if you're not careful. So this one needs to be used with caution. Yeah, so the next advanced feature that I want to kind of show off is taint tracking. So earlier I did say that Semgrep doesn't have support for taint tracking, which is a kind of like a lie, because it has partial support for intra-file taint analysis. What this means is that if all of your source and sinks are from a single file, Semgrep has partial support for it. There's a bunch of caveats and things that it doesn't work on, but it's still actually kind of usable. So it is actually enabled with the mode taint option in your rule, and it allows you to use 3 new operators: pattern sources, pattern sinks, and pattern sanitizers. So if you have done taint analysis before, they should be pretty familiar. The sources are where your user inputs come from. The sinks are where you're interested in seeing if your source flows to. So a simple example could be you have user input from your web server coming from like a HTTP request, and you want to check if it flows out to something that displays HTML output, right? Because if you want to check for cross-site scripting, if you're just taking unsanitized user input from your HTTP request and passing it to your output, it could result in a cross-site scripting attack. So what Semgrep allows you to do is see if any of that thing happens. And you can also specify like the pattern sanitizers flag as a way to say, hey, if there's a flow from a source and sink, but it passes through this sanitizer function, it's not actually relevant, so don't flag it out. Yeah, let's look at that example now. Right, so this one is a little bit more complex. So I have 3 different functions on the left. The first function on the top essentially takes data from a function called get user input, and it just passes it to this output function without anything in between. The second function, on the other hand, takes the same data, but it passes it through the sanitized user input function before returning it in the output. And the last function over here takes in two different calls for user inputs, the data and the additional flag. And it only sanitizes the, oh, sorry, this one is a typo that I need to fix. Right, so it only sanitizes the additional flag, but it passes data to the outputs. So this is three different scenarios that we want to show in the Semgrep rule. Yeah, so I have a rule over here that says I'm interested in anything coming, any sources coming from get user input, and the sink is the output function. And the sanitizer I have is of course, the sanitized user input function. So if I run this right now, you see it actually matches things like things on line 4 and on line 21. So on line 4, it's immediately obvious because you're taking user input and you're just passing it to output. There's no sanitizer function in between. So it actually matches our rule and it should return. The second function, of course, it goes through the sanitized user input, so it doesn't match. But in the last function, we call the sanitized user input on the additional function, but we are using the wrong variable in the output data. So you can kind of see from this example that Semgrep is aware of where the data comes from. Yes, so like Daniel mentioned in chat, you can actually chain things together with calls to Semgrep. I think they have a new feature that allows you to run multiple different rules in a single file at once to kind of approximate interfile tail analysis. But I don't think that's quite the same thing because I don't think it actually tracks the variables properly. So I might be wrong on that. I need to play with it and see. Okay, so that's all for the technical examples that I have. It's kind of like the simple ones to show you the power of Semgrep. Let's talk about some use cases for it. And I think the most obvious one is obviously you want to find security bugs. If you're, for example, a researcher or you're doing a penetration test, and you want to do a code review on a code base to find bugs. The thing about Semgrep, like I mentioned before, it has less powerful capabilities compared to something like CodeQL. So I think it needs a different approach when using the tool. So you shouldn't expect it to automatically find exploitable bugs, but you should instead use it to focus on problem areas in the code that you can do manual review on. So like Semgrep is in the name, right? Use it as a grep. And because the rules are very easy to write, you can actually use an iterative workflow when doing a code review. So what this means is that you can run Semgrep with a base set of rules to find problem areas in the code that you do a manual review on. So you've gone in and done the manual review and you found a vulnerable pattern that's exploitable. And you want to check if that pattern is present in other places in the same code base or even in different code bases. You can then write a new rule to find out more places with this specific pattern, then go ahead and do that manual review on other places, and it's a cycle that feeds, right? So you have manual review feeding into more rules, which opens up more areas for you to review. And I think that's a fairly effective way of finding bugs with Semgrep. Sorry. The second way of using Semgrep, not second way, but if you're a software developer and you want to enforce code quality in your code base, you can use Semgrep in a CI/CD pipeline to do things like ban dangerous code patterns or functions in your code base. Like you might want to, in Python, ban the use of the pickle function, or in JavaScript, you might want to see if anyone calls out to like shell commands and so on. And you can use it to enforce best practices across the entire code base automatically. And because Semgrep is very, very quick to run, you can actually run it every time a commit happens, as opposed to the rules that the tools that need a lot more compute power, where you might only run it as you're about to deploy something into production, for example. So the feedback cycle is actually very useful in picking up bugs immediately when it's written, rather than like 5 months later when you deploy something. Because Semgrep rules resemble the language that you're analyzing, it's essentially like Python code or Java code. You just replace like different patterns with dots here and there. Very similar. It's simple for developers to write new rules. And especially it's especially simple for developers to tailor your rules to the code base being analyzed. I think there's nothing less effective than a like static analysis tool that you don't do any tuning on or any configurations on, and you run it against a code base and hope for good quality results, because you're just going to get a lot of false positives. And the way it usually works is that you have like a security team in a company that sets up all of these scanners, and you run it against a code base, and you throw all of the findings across the wall to the developers. And the developers don't have any inputs on whether those findings are valid, whether they are useful, and so on, which is not very effective. So if you're using something like Semgrep, where the rules are easy to write and customize, you can tailor the scans to the very specific code base patterns that you have and you're interested in. If you're an organization, you can also use vulnerabilities that you've got as a feedback loop for Semgrep rules. So you might have vulnerability reports coming in from penetration tests or like bug bounties that you've run. After you've patched the vulnerabilities, you can do like a root cause analysis to find out, hey, what actually caused the bug? What's the problem area in the code? If it's like a SQL injection attack, is it because the developers are not using prepared statements? And you can write a Semgrep rule tailored to that vulnerability to eliminate that pattern throughout the code base. So hopefully you don't get repeated reports from your pen tests or bug bounties over and over again. Yeah, I would just like to end with this quote I've taken from a Wired article on how Facebook does static analysis internally. So what they did is actually they have a like in-house tool called Zoncolon. I'm not sure if they're still using it now. It's a pretty old article. And I think the key line over here is that they create new rules in their static analysis tools to match things coming from like their company bug bounty programs and so on. Right, so the initial line says that initially they had like a bunch of engineers doing manual review on the code, but now they have this static analysis tool. They'll just write a new rule to eliminate that in practice. Yeah, so that's actually all I have for the talks. If you're interested in like the very simple examples I have, it's on the GitHub repo, but you should really check out the Semgrep website because the tutorial is actually very good. And yeah, are there any questions? So Ben has a question on, are there any existing comparisons to Joan and CodeQL? So I did a comparison to CodeQL right at the start of the talk. Yeah, so like I said, I think Semgrep is less powerful, but it's a lot faster to run. And I think the rules are a lot simpler to write, which has this like nice feedback loop. And CodeQL, although it's technically free for open source tools, yeah, although it's technically free for open source tools, you can't actually run it on like a private code base unless you pay for a license. And it's again on like the enterprise level, contact us for a code expensive. Joan is pretty similar to CodeQL. I think it has a lot more powerful capabilities, but it's only limited to C and C++, if I'm not wrong. So I think if you're writing rules for C and C++ code base, Drone would be a better option. But I think if you need something for Go, for Java, for Python, Semgrep is good. Kelvin is asking is there a way to write queries on the fly? So they have a browser thing that you can use. Let me show it now. So they have a playground online, right? So you can write the rule over here, and you can dump some code here and use it entirely in the browser. But I don't really like to use the website. I just have my code editor, and Semgrep is a command line tool that you can just run. Yeah, you can use the -e flag for matching expression. So essentially like a grep replacement.
Hi, I have a question. I saw that you found some command injection bugs on patrolling router. Did you use this to find that?
No, because that's from a binary, so it's not source code. It's like a compiled binary, right? So I used binary ninja and tools like that to find. But that was mostly like messing around doing manual reviews. I didn't really automate any of that.
Oh, okay, good. Thanks.
So there's a question saying it's mainly advanced textual matching. Assume it's hard to write rules to find contextual bugs like type confusions. Yes, I think if you want to do it like without any false positives, it's not really that reliable. Because especially for like dynamic languages, like it's pretty difficult to know like the type information for each variable, right? So just from static analysis, without any like advanced SMT solvers and things like that. So yeah, I mainly use it as a advanced textual pattern matching kind of thing to fit into like manual code reviews. But it might be possible. I've seen some like advanced rules, but I just don't know like how reliable they'll be in practice. I think if you want anything like anything complicated, any like data flow analysis, type analysis kind of things, I think CodeKR is still the better choice if you have access to that. Are there any other questions? I don't think so.
Okay, if there's no more questions, then I'll be moving on. Okay, so thank you, Terry, for sharing all these valuable information with us. Next up, we'll be having a networking session where you are free to chat with any one of our guests or just hang around to chat with anyone. So we'll be using Gather Town for this networking session, and I'll be pasting the link in the chat. Yeah, so you can join there now.